So 3.7 is called sinusoidal function context and data modeling. We now know context and data modeling mean word problems and regressions because we've done it with logs, we did it with quadratics, we did it with cubics, okay? Now we do it with sinusoidal functions. So we know this, we talked about it yesterday. This is your standard form of sine and cosine. The A on the front, the sign on the A would determine if there's a reflection. All right, so the A on front, the sign on that A determines which direction it goes. If it's positive, it's your typical one. If it's negative, it flips it over the x-axis. The value on the A is your amplitude, right? The B is your horizontal stretch or shrink, and it affects your period because 2 pi over B is your period. The C would be your horizontal shift to the left or to the right. Positive goes left, negative goes right. And D would be your vertical shift and also affect your midline vertical shift. If it's positive up, negative down, and then midline would be y equals d, okay? Well, now we're going to pick it apart. So this one says the function f oscillating between output values of -1 and 7. The table below gives the values of the function for selected values of x. Without using technology, write a sinusoidal function to model the data. So we need to figure out all the parts, okay? I would say starting with max and min is typically where I start. I feel like that's easiest to figure out, and then that will give you your midline and your, God bless you, your midline and your amplitude, okay? So your max is what? 7. Your min is -1. Min, -1, max, 7. So right away from this information, you can get 2 things. You can get your amplitude because max minus min over 2 is 8 over 2 is 4. That gives you your amplitude, which is your A. Max plus min divided by 2 is going to give you your midline. So 7 plus a -1 over 2, 6 over 2 is 3. That's your midline, and also, well, y equals 3 would be your midline. This is also your vertical shift. Then we can figure out our horizontal change, right? So we need to know from start to finish when would it complete a whole curve. And this you got to be careful on because technically if you look 3 repeats, right, and -1 repeats. So if you want the visual on it, if it was 0, -1, I'd be here. And then pi, 3, 1, 2, 3 would be here. 2 pi. Okay, so I plotted the points they gave me. 0, -1, pi, 3, 2 pi, 7, 3 pi, 3, 4 pi, -1, and 5 pi, 3. And the reason I did it is because it gives you the overall shape of what you're looking at. And for me, it's a little bit easier then to read your period, okay? Because you cannot go from 3 to 3. That is not a full period. It hits 3 at pi, it hits 3 again at 3 pi, but we have not completed a full curve. So if I'm actually looking for the full curve, if you were given this picture and you were looking for the full curve, you can start here. It's going to go up and come back down and finish here. And that's one complete period. So what is the length of the period? 4 pi. And then from there, I need to find B. B is 2 pi over the period. So this is going to be 2 pi over 4 pi, which is 1/2. So I need an amplitude, because that's my A. I need a midline, because that's my D. I need to take and manipulate the period to get B. And last thing, well, not last thing because we'll also look for a reflection, but the next thing would be what does my curve look like? It said sinusoidal. It didn't say cosine or sine, so we get to pick. So if I went off of the curve I just drew, what would you say that is? And I'll tell you right now, there's more than one answer. But what's one option? It could be a cosine. If it's a cosine, then what has to be done? Has to be reflected. So it could be a -A with a cosine. Yes. What else could it be? It could be a sine that is horizontal shift to the right, pi. So it makes sense there could be 2 answers here. Yes. I feel like the cosine's easier because you don't have to deal with a phase shift. but it doesn't mean that's wrong, okay? So you do have to have a reflection, but you don't have to have a phase shift, which means the C is 0. I don't have to add or subtract anything on there. But it means my A is a negative 4. You guys with me so far? Okay, now we build it. So f of x, it gave me f of x in the data chart, so I'm going to use f of x equals. All right, so it's a negative 4 for the A. All right, so we made it a cosine, okay? We said B was 1/2. There is no C, so I don't need to add or subtract anything there. And then the midline was 3, so my D is a positive 3.
Could you write out what the sign would be?
Yes. Questions on that one so far? So on your FRQ, it won't be a data chart like that. It will be a paragraph with that kind of information. And then it will say, what is A? What is B? What is C? And what is D? Okay. And you get points for A and C, and you get a point for B and, or no, you get a point for A and D together, and you get a point for B and C together. If you get A and B wrong, you lose all the points because you lose the one for the A and the D, and you lose the one for the C, B and C. So be really, really careful. If you miss one of those 4, you still get the other point, but you got to be really, really careful. Yeah.
Does it matter if you put theta or x?
So if it gives you X, obviously put X. If it doesn't give it to you, and usually they don't, it's a word problem. It doesn't matter, and it usually doesn't even ask you for the full equation. It asks you for A, B, C, and D. Okay, so now let's say we had done it, because this could also be in your multiple choice section, and it could say which of the following could represent this function, and it might give it to you in terms of sign, okay? So now let's say we use what I just highlighted in green as your sign. The A is still 4, but it's not negative because that's a positive cosine. I mean, a positive sign. So A is still 4. The period's still the same, so the B is still a half. D is still your midline, so that's still 3. What changes is your phase shift. So if we are starting here and going this way, okay, then I'm starting at pi, which means there is a shift to the right pi, and if it's going to the right pi, what is C? Minus pi. So this would be f of x equals positive 4 sine 1/2 parentheses x minus pi, close them, plus 3. And I will tell you that this is one of the most confusing parts for when we got to like review for our kids, when you start to bring back in the old transformations, because when it asks you for the C carries the sign that's there. It technically goes the other direction, but when I ask you for C, it's negative pi. You are moving to the right, but our C is negative pi. In our original transformations, it doesn't. So that's where sine and cosine get to be confusing. But it is because those parent functions, like when we'll do parabolas and that kind of stuff, in the original equation it has a minus in it, but in sine and cosine it has a plus in it. So C carries the sign that would be in the equation on these. Any questions? Because this is huge. Like this is 1/4 of your FRQs. At the minimum, it will also be in your multiple choice. All right, example 2. A sinusoidal function is defined by, so now they're being specific, it wants it to be sine. The function contains the input-output pairs of 8 pi, 18, and 40 pi, 18, which represent consecutive max values on the graph. What does that mean? That's one full period. Good. So 8 pi and 18 is a max, and then 40 pi and 18 are maxes. So it could look like that, okay? What's the period for the function? How long does it take to make the one complete curve? 32 pi. Good. What's the frequency? 1/32 pi. And remember, b equals 2 pi over the period. So 2 pi over 32 pi is 1/16. So they did not give you any information about a minimum, which is why they didn't ask you about A, amplitude, or D, or midline. This was all just end point to end point of your curve. Still good? All right, example 3. The sinusoidal function is defined by cosine, okay? The function contains input-output pairs of 0, 42, and 6, 18, which represents the max values and a minimum value, respectively, on the graph of f. So now, 0, 42 is a max, and 6, 18 is a minimum. Now I have top and bottom. So what are the values of A and D? What do I do to get A?
Max minus min over 2.
Good. 42 minus 18 over 2. 24 over 2, which is 12. That's your A. And to get D?
Max plus min.
Good. 42 plus 18 over 2. 60 over 2, which is 30. What's the equation of the midline? Good. And then C says, what's the output value when the input value is 12? So if from 0 to 6 got me from max to min, what's going to happen from 6 to 12? It's going to go back up to max. So what would be your output value? 42. Yeah. I went from max to min, so it's half of my full curve, right? Max to max would be a full curve. Max to min is only half. So if I want to go, that's if it goes halfway, 40 from 0 to 6 was half, then I would have to go another 6 to get to the next max. Does that make sense? So from here, what would be your period? 12. So max to max or min to min is going to be your full period, but max to min or min to max is half your period. Does that make sense? Okay. All right, now it says a sinusoidal function models the average New Orleans temperatures in Fahrenheit as a function of time in months after January 1st. According to the model, the highest average temperature is 92 degrees, occurs about 3 weeks into July, and the lowest average temperature of 57 degrees occurs about a half a year earlier. Write a cosine equation for T of T. All right, so think about all that information, right? First of all, we're starting at January 1st. So this is like 0 is January 1st. Then the highest average temperature happens 3 weeks into July, and it says it's about 6.7. 6.7 is the highest temp, max, which is at 92 degrees Fahrenheit. And the lowest average temperature of 57 degrees occurs about a half a year earlier. So what's a half a year earlier than 6.7? 0.7. And this would be my minimum. That's 57 degrees. So now let's think about what we've got. Do your max and min first, right? Max minus min divided by 2 is your A. So 92 minus 57 divided by 2. 35 divided by 2, or 17.5. You could literally leave it as 35 over 2, or you could make it 17.5. Both are going to be okay. That's your A. Then we get D from doing the midline, so 92 plus 57 divided by 2 149 divided by 2. And again, that could stay that way. Or you could do 74.5. That's D. You still with me? Okay, now I went from min to max. Yes? Is that the period or is that half the period? It's half the period. So the full period is? Well, this was, yes, 12, sorry, from 0.7 to 6.7. So the full period is 12, which makes 2 pi over 12 b, which is pi over 6. And then I got to figure out what the shape of my curve looks like. Here's my min, here's my max. It's going to come back down again to the min. So if they want you to use cosine, is there a phase shift? Yep, to the right, which means positive or negative? Negative 0.7. And regular cosine or reflected cosine, which means negative 17.5. So now you got to put it all together. T of t equals negative 17.5 times cosine of b pi over 6x. You need the parentheses because you have a c this time. Minus 0.7, close them, plus 74.5.
Why'd you put parentheses before cosine?
Well, I mean, it doesn't really matter. I'm just grouping the cosine together. You don't, I mean, that doesn't matter. These parentheses matter. That one doesn't matter. Yeah. So this said this was my minimum. Right? So that's where we're starting the curve. We went up and we're coming back down again. So we're saying that's the start and that's at 0.7. But it's to the right, so it has to be minus 0.7. So you're looking for either a max or a min to start your curve. They gave us the min first. Well, they gave us the max, but the min came before it. The minimum's the start of your curve for cosine, well, for a reflected cosine. They said it was shifted, right? I mean, it can't start here because this is going to come back up again. So you have to find, for cosine, you started at a max or a min. A max if it's a regular cosine. A min if it's a reflected one. We'll come back to 6.7 is where the max happens. So you could, because that's an option. You could start your cosine all the way over here and you could go like this with it. Now it's not reflected. But your phase shift would be a negative 6.7. So you certainly could, and that answer would be right. Does that make sense? Okay. Okay, it says, according to the model, what's the average temperature on the last day of October where T is 10? How would I find that? Plug it in. That's your input value. So you can either write this whole thing as your Y1, and then you can find Y of 10. Or you could literally type it in, cosine pi over 6, 10 minus 0.7 plus 74.5. You would have to make sure your parentheses goes there. So how you can do it one way or the other, okay? You could do it both if you wanted to check it. God bless you. Negative 17.5 cosine pi over 6. Open the parentheses. 10 minus 0.7, close them again, plus 74.5. And then I can do Y1 of 10. You just need to make sure radians are on, right? Because pi over 6 is a radian measure. Your calculator stays in radians. Like the moment you reset it, it's in radians, keep it in radians, okay? For your actual test, 71.762 degrees Fahrenheit should be your answer. What is the average temperature on the last day you're giving it to in terms of the temperature? That's it. You could have also literally taken 10 and plugged it in here. So I could have done 10 minus 0.7 times pi over 6. Then find the cosine of that value. Then multiply it times negative 0.17.5 and then add 74.5. So if it's weird by you typing it in, you could always break it apart. All right, temperature in degrees Fahrenheit in Florence, South Carolina on a certain day at selected times t in hours after midnight is shown in the table below. Use a sinusoidal regression to find the model for the data. What is a sinusoidal regression model? How do you do that? This is where you run the regression on your calculator. So we're typing in that table. It's been a long time since we've done this, so you need to make sure you go through the motions.
Don't you need to turn on anything or not?
To run the regression, no. To C and R squared, you're not doing that yet. To C and R squared, that's when you have to turn that stuff on. So I'm going to type it in. If you wanted to see what it looked like, you got to turn on your stat plot, but we don't need to see it. So 0, 3 is my list 1. 0, 3, 5, 9, 12, 16, 20, 24. And my list 2, 68, 64, 61, 65, 75, 78, 72. And 67. So I'm in list 1 and list 2. And then when I go to stat and you go to edit, there is a sign reg. It is C on your list. And you're going to run it. We're going to answer a question based on it, so my advice would be to store it in Y1. And I get Y equals, so it would be F of T equals 7.9468, so 7.947 sine. The B is 0.279, so 280.
Do we leave iterations as 3?
Yeah, iteration just means like how many periods you want. You can leave it as 3. Now notice that your sinusoidal function on here says A sine bx plus c plus d. There are no parentheses within the parentheses. So when you write it, you don't put parentheses within the parentheses. It would be 0.280x minus 2.938, close the parentheses, plus 69.935.
Why isn't that on the outside?
Like, why are there no parentheses within it? Because if you look at it, like where it says y equals, this is what it looks like. It does not have parentheses next to the b. And it's always going to be sine. They don't do cosine. Your calculator doesn't run a cosine regression. Yeah.
But then why do we do it differently than the calculator?
Because you could distribute it in every time, but it's easier to not.
Oh, it gives that value.
Correct. It's easier to not do it. If it's distributed, then that is technically C times B, which it's easier to not do that. Yeah. Okay, so use the regression model to predict the temperature at 2 p.m. or where T is 14. So I'm going to run my Y1 of 14. What'd you get?
76.
Good. Degrees, what does it say? Fahrenheit. And if it could ask, like, what day in the first year, because it would have to be specific to the period, does it hit a certain temperature? Because this always duplicates, it would have to give you some sort of a range, or you could have more than one answer. Which of the following months or days, was it days? Yeah, which of the following days, hours, sorry. At which hour did it reach this temperature? And that's where you would want to do your Y2 and see where they crossed. We good on this? Yes? Okay, last one. It says a weight attached to the end of a long spring is bouncing up and down. As it bounces, its distance from the floor varies sinusoidally with time. You start a stopwatch. When the stopwatch reaches 0.3 seconds, the weight first reaches a high point of 60 centimeters above the floor. The next low point, 40 centimeters above the floor, occurs at 1.8 seconds. It says sketch a graph and find the following. So start your graph. What piece of information did I give you?
0.3 is 60.
0.3 is 60, and 60 is what?
The max.
A max. I should not. I'm going to do it below it so you can see it better. 0.3, the max of 60. Okay, what's the next piece of information given?
40 at 1.8.
It hits a low point of 40 at 1.8. So what's 40 represent?
The min.
Min. Is that a full period or is that half your period? That's half your period, which means, so if I did 1.8 minus 0.3, this is 1.5. So it would hit another max 1.5 later, so 1.8 plus 1.5, 3.3.
And then that would be the other max.
That's the next max. So it says, what are the max points? One's at 0.3, 0.3, 60, and 3.3, 60.
Our period's 1.5.
The period would be 3 from start to finish. 1.5 is half of it,
Oh.
right? The min point, there's only one this time on this curve, 1.840. And now we got to come up with our cosine equation, so we need all the parts. So we need an A, max, minus min divided by 2. 20 divided by 2 is 10. Is it a positive A or a negative A? Positive, or we'll leave it alone. D, max plus min divided by 2. 50, that's your midline. Our period was 3, good. So B would be 2 pi over 3. And is there a phase shift? Yep, we're starting where? At 0.3, right? So C is positive or negative? Negative 0.3. So on your FRQ, those are the parts it's looking for, A, D, B, and C. This one asks you to build the cosine equation. It didn't give us variables this time, so we could just make it f of theta. You can make it f of x. You can make it f of t. I don't care what you make it, okay? Equals, your A was a positive 10 times the cosine, B, 2 pi over 3, open those parentheses again, theta minus 0.3, close them again, plus 50. And again, you could have made your variable x, you could have made your variable t, it didn't matter. But whatever you made it, you want to match it. Questions? All right. So these are always going to end up being word problems. You always have to make sure you pinpoint those pieces of information. Max, min, period, which would be max to max or min to min, or half the period would be max to min or min to max. And then your A, your D, your phase shift, your period. All those things you got to piece together from them.